Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is longest common subsequence, and the problem statement goes like this. Given two strings text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, then you have to return 0. So for those of you who do not know what a subsequence is, a subsequence of a string is a new string generated from the original string with some characters, can be 0 also, deleted without changing the relative order of the remaining characters. So what do the problem statement mean by this is, so let's say a string ABCD is given to you. Now let's say we decide to delete C only, then the remaining string will be ABCD. Okay. So the remaining strings become A, B, D. This is a valid subsequence, but if you go for A, D, B, this is not a valid subsequence. Why it is not a valid subsequence? Because D is coming before B. If you mark the indices of these two, then you will see that index of D is greater than B. So this one is not valid, but this was valid. Okay, so this is what a subsequence is. For example, ACE is a subsequence of ABCD if you delete B and D. Okay, so a common subsequence of two strings is a subsequence that is common to both of the strings. So for example, these two strings are given to you. A, B, C, D and E, and this is one string and another string is ACE. Okay, this is second string. Now if you were to find out what is the longest common subsequence, just by observing you will be able to know that this is the common subsequence, longest common subsequence that we have. It is ACE. Now let's say we are having one character extra. Here let's say there is F, and here also there is F. Okay, now as you will be able to observe that longest common subsequence is ACEF. Now there can be a subsequence which is something like this, ACE, and there can be another subsequence ACF. Although these two are not longest common subsequence, but since in a brute force way, uh, before that let's see what the constraints of this particular problem are. So the lengths of both of the strings will be of order 1000 and only lower English letters are there. Okay, these were the constraints. So let's consider a brute force approach. In this brute force approach, we will be trying to generate all the subsequences that can be there as a as a combination of uh, subsequences of these two. What I mean by this is, for each character you will be having three choices. What are those three choices? Let's say you are on the let's use two variables, indices, index 1, and let's call this one as index 2. Okay, so let's say you are on this particular index at the first text, and this particular index at the second text or the second string. So you will be having three choices. First one being that you can skip this character if it's not matching with the character that is currently represented by this index 1. So if we can skip this character, or else what we can do is, if these two characters are not matching as of now, we can skip this one instead of C. So what we can do is, let's say we are calling a function LCS and we are passing string 1, string 2, and these two variables, index 1 and index 2. Okay, then we will be having one choice that if let's say the characters that are represented by these two indices in these two different strings are not equal, then we will be having two choices, either to exclude this index in first string or exclude this index in second string. Okay, so one choice that we will be having is, we can remove this particular index or exclude this one and take this one. Okay, so index 1 can be skipped and index 2 can be included. Okay, this is one way. Another way that can be there is LCS of text 2. Let's say we decide to take index 1 and exclude this one. So index 1 plus will be taken and your index 2 will be skipped. Okay, so this was one way, this was another way. Now let's say the characters are matching. If let's say instead of B here, this index 1 was pointing to C here, then you will be able to see that these two characters are same, they are matching. So what will be the third option that we will be having in case of matching characters? It will be A, that we include both of the characters from both of the strings. It will be LCS of text1, text2, and we are including both of the characters. So 1 will be added, since your LCS will be increased by 1, since you are adding one character to your longest common subsequence. Okay, and in that case you will simply be proceeding further both indices. Okay, so this will be the third case in case of a match. This was the case in which you were taking second index. This was the case in which you were taking first index and excluding second indexed characters. Okay, so among these three operations, whichever option is giving you the maximum result, you will return that option. Okay, so but there is a little problem here in this recursive approach. What is the problem? Let's say these were two different subsequences. Let's call this subsequence 1 and let's call this subsequence 2. Now as you are able to see that here this part in both of the subsequences is common, so you will be doing extra work for calculating this part again and again. Extra work will be there for the computations. Now what happens is, let's say the length of these two strings are len1 and len2. Okay, now each of the character is having three choices, and this will be continuing till minimum of len1 or len2, minimum of these two number of times. Okay, so what was the order of len1 and len2? It was 10 raised to power 4. Okay, 10 raised to power 3. Okay, this was the order of their lengths. Let's say len1 is the minimum one. Then how many number of times we should be running this particular recursive solution? It will be order of 3 raised to power of minimum of len1 and len2. Okay, number of times it will be 1000 in worst case, and 3 raised to power 1000, let me take it to another slide, is a very large number as compared to 10 raised to power 8 operations. So this will be the number of operations required by your program. In case you apply this recursive function of trying out every combination. Okay, and this is our operation limit. If the number of operations in your program exceeds or become equal to this operation limit, then you may get a TLE and your solution will not be accepted here. So in order to get your solution accepted, you have to optimize this particular approach. Brute force approach is needed to be optimized. Now if you see here, let me take it to another slide. Okay, in this particular example here, this part was common, which was leading to extra work. Okay, so let these be two subproblems of a bigger problem. Then we can easily see that there are overlapping subproblems. Okay, so a subproblem is common in more than is occurring in more than one subsequence. So there are overlapping subproblems. The first observation is so the problem statement or the problem that is given to us is having overlapping subproblems. Now let's make the second observation. ACE. If we were to find what is the longest common subsequence on this particular character, then we have to know the answer for previous ones. Not on this particular character, you can say that, let's say we are on a particular index on the first string, text 1, and we are on a particular index at second string, text 2. So the state, that is current state, will be represented by these two variables. Okay, so your current state will be represented by these two state variables. So let's call this LCS. LCS of, if you want to know LCS of index 1 and index 2, then you should be knowing your previous states. This one is your current state. Why I am talking about that you should be knowing your current state, otherwise how you will be able to make sense that, let's say you have already formed a length 2 common subsequence beyond this point, or it was a length 3, it can be of any length, it can be of zero length also. How you will be able to know? So in order to calculate this part, you have to know what were the previous states giving us. Okay, so what was the longest common subsequence formed, length of longest common subsequence formed till now? So it was indeed 2. Okay, before this particular point, let's say this particular point was denoted by LCS of index 1 and index 2, then you have to know this. So it can be observed that solution of bigger subproblem can be formed by combining solution of smaller subproblems. Let's call this solution 1. Let's call this solution 2. Let's call this solution 3. These are solutions of smaller subproblems, and you can combine them and you will get the solution of bigger subproblem. Okay, so this was second observation, and this property is called optimal substructure. So whenever these two properties are satisfied by a problem statement or a problem, then a technique, optimization technique, it is basically called dynamic programming, can be applied. Let me write again. Okay, so those of you who are new to these three things, I will be providing links of articles describing how these things work out, what are these two properties, and what is dynamic programming. Okay, right now what I can tell you is about dynamic programming, that you keep storing your states. Your, let's say, intermediate states, and whenever these states repeat, instead of doing computations again and again, you will use the stored results for those states. Okay, so here, as you can see, this particular state was results was already calculated and let's say stored somewhere. Okay, so let's say we stored it here. Okay, so in this particular data structure, let's say we stored the result. Then whenever this particular subproblem or state is occurring again, then instead of doing recalculations again and again for this part, we will be using the stored result. So we will be avoiding extra work. So this extra work will be eliminated. Okay, and what other than avoiding extra work will lead us to? So other than avoiding extra work, you will be building your solution of bigger subproblem with the help of smaller subproblem. Okay, so this is the other thing that you will be doing in dynamic programming. Okay, so this is just a layman definition that I am providing just to make you understand if you are seeing it for the very first time, and you can certainly go over the links that I will be providing you and you will be able to understand what dynamic programming really is. Okay, then let's move back towards our approach. So let's say we came to know that a state here in this particular uh, problem will be represented by two variables, index 1 and index 2. What index of text 1 we are on, or say the first string, and what index of text 2 or the second string we are on. That will determine your current state. So let's say this is your current state, LCS of index 1 and index 2. So what were the three options? Let's say we characters present at index 1 and index 2 in strings text 1 and text 2 respectively are not matching. So in case of not matching, what will be the previous states possible? How you could have ended up on this state? So let's say you were at this state previously. Okay, then you could have just taken one step forward and ignored this particular character, and you could have ended up on this state, current state. This can be previous state 1. Okay, now what can be other previous state? Other previous state can be LCS of, let's say you were at index 2 minus 1, and since those characters represented by these two were not matching, you decided to make a jump of one index in the second string, and you ended up on the current state. So this can be another possible previous states. So in case of not matching, what are not matching? The characters at this particular string, at this particular index in this particular string. So text 1 index 1 is not equal to text 2 index 2. So this is case of not matching. Then you will take maximum of these two previous states. Okay, so LCS of index 1 index 2 will be maximum of previous state 1 and previous state 2. So in case, let's say, also even in case of matching, if let's say the characters are matching, even then you can decide to take maximum of these two. Okay, so in case the states are matching, your LCS will be certainly increased by 1, since a new character will be added that will be common to both of the subsequence. Okay, so you will be having two options. Either you can take the new character in your common subsequence, or you can ignore that new character altogether. Okay, so what will be two options? Let's call this that this was the earlier value that we were getting for LCS. So you will be having two options to take. Either you can take whatever the value is currently present in your current state. Okay, this was the option that I forgot to mention here while describing the recursive approach. Okay, I am describing it right now. So either you can pick up whatever the value is currently in the LCS, or what you can do is you can add this character that is common to both of the subsequences, common to both of the strings, and you can proceed further. Okay, so this could have been the case like LCS of index 1 minus 1 index 2 minus 1. Okay, so these two characters represented by these two indices were matching, and okay, and we decide to take a jump forward. Okay, this will be that case. Okay, and it will add 1 to our longest common subsequence. Okay, so we will be taking maximum of these two operations. Either you will be including the matching character or excluding the matching character. This is excluding the matching character. And this one is including the matching character. In LCS. So seems like we have a transition equation. So let me show you what will be the transition equation and how I will be implementing this solution. So this is the transition equation. Okay, so there will be two different cases. One case is that if there are matching characters, if the characters present at current state are matching. Okay, in that case you will be having two options. Take matching character or exclude matching character. Okay, so these two options will be you will be having: taking the matching character and excluding the matching character. So if you ask what these statements are, these are nothing but the boundary checks that I have implemented. Since you will be taking index 1 minus 1, so this value should be greater than minus 1 in order for it to be fitted in zero based indexing. Okay, you cannot have negative values here. And this will be the case that in case we are not having any matching character, or even if we are having matching character, then this case can be applied even then. So in case of mismatch. Okay, so either you will be coming from the one index back from the first index, previous from the first index, or you can be coming from one index previous from second index. Okay, and at last you will return your LCS simply. So this is how we will be solving this particular problem. And if you ask what will be the time and space complexities here, those will be, for time complexity part, let me write it, it will be order of len 1 cross len 2. Okay, so since we are having two nested loops, and if the space complexity you may ask, then it will be same. Since you are having a 2D vector or say array here, this will be used to store the intermediate states. This will be used to store the results of intermediate states and form the solution of bigger subproblems based upon solution of smaller subproblems. This will be to avoid extra work, to avoid recalculations or extra work in case of overlapping subproblems. Okay, so this will be used to store the results of intermediate states to avoid extra work in case of overlapping subproblems, and to form the solution of bigger subproblems based upon the solution of smaller subproblems. So for the space complexity part, it will be same, nothing different here. Okay. So this is how the solution will work. If you are still having any doubts or any queries in general, please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.